Okay, so today we're looking at Module 6, Lesson 5. If you look at the lesson summary, it says the graph of a function can be used to help describe the relationship between the quantities it represents. So we know that when we're looking at a graph, you have your axes, and they're labeled to represent what the graph is representing. So keep that in mind, that each of these graphs that we look at represents something. So in our lesson summary, it says, a linear function has a constant rate of change. A non-linear function does not have a constant rate of change. So what I want you to do is, above that word linear, draw a straight line. We've talked about how linear means straight. I have a straight line. Non-linear means it's not straight. That prefix means not. So draw yourself some sort of curvy line right there. I drew like a little hump. Kind of like the graph I see right here, but nonlinear means not a straight line. And there's more notes that say a function whose graph has a positive rate of change is an increasing function. A function whose graph has a negative rate of change is a decreasing function. And then it says some functions may increase and decrease over different intervals. We saw that example in some of our problems from the previous lesson where the cell phone problem, they were being created at a constant rate, and then production stopped, so the production slowed, and then the rest of the graph went straight up because they continued production. So keep in mind that it could be increasing and then stay steady and then decrease and then increase again, just all the different things that could be represented by our graphs. So looking at number 1 of our problem set, read through the following scenarios. These are the scenarios A through D, and match each to its graph. Explain the reasoning behind your choice. So again, here are my scenarios, and then on this first page I have 2 graphs, and if you turn the page, you have 2 more graphs. So you have A, B, C, D, a total of 4 scenarios and 4 graphs. So let's read through these. As I read, I'm gonna underline my key words. So this first one, A, this shows the change in a smartphone battery charge as a person uses the phone more frequently. Okay, so a key word here I would say is uses more. That kind of tells me what I'm keeping an eye out for on that graph. This one says B, a child takes a ride on a swing. There's not really a key word there, but if you think of a swing, it goes up and down, right? You go forward and backward and forward and backward. You kick your legs. C, a savings account earns simple interest at a constant rate. Your keyword there is constant rate. So we know we're going to have a linear function, which is a straight line. Remember, a linear function has a constant rate of change. And then D, a baseball has been hit at a Little League game. Well, we've talked about the baseball scenario in the past, so keep that in mind. A baseball is hit at a Little League game. So we're talking about the baseball and how it would be represented on the graph. So now that I look at these scenarios, I know for a fact that C is going to be a straight line. It's a constant rate. So the first thing I'm going to do is look at my 4 graphs. This one, this one, this one, and this one. And I'm going to see, are any of those a straight line? This one's a straight line. This one is not a straight line. This one's definitely not a straight line. It's like the waves of the ocean. And this one's not a straight line. So I know just by doing the process of elimination that this one right here, this graph, represents C, a savings account earns simple interest at a constant rate. And I know that without a doubt because if you look, it says constant rate. So it's my only one that's a straight line. When you have a savings account, it earns interest, meaning you earn a little bit of money based on the percentage that you have on your savings account. And so your savings account, say you put in $100, it grows a little bit as that $100 sits there. A lesson for another day when you get to high school and you learn about finance, but that's your savings account scenario. So this one, if you look, this graph starts right here, up a little bit from our 0 value. It goes up, and then it comes down. All right. So let's look at this. This shows the change in a smartphone battery charge as a person uses the phone more frequently. Well, if this was like my smartphone usage down here, and this was my battery charge, it would show the charge going up as I use it and then falling down as I continue to use it. So that doesn't really make sense that as I use it, it goes up. It would just be constantly going down. So I don't think that's it. And then a child takes a ride on a swing. Now picture it. Like I said, when you kick your legs forward and you kick your legs back, and you kick your legs forward and you kick your legs back. So it's up and down, just like the picture I represented. So that might be one kick, but that's not riding a swing. That would just be going forward and then stopping. So that's definitely not it. And then look at this one. A baseball has been hit at a Little League game. If you think back to a few weeks ago, we had the lesson on someone was throwing the ball, and they threw the ball from their hand, which, if you think about it, isn't on the ground. So if this was the ground and then this was the ball, they throw the ball, and then it eventually falls down, right? The ball is always going to fall down or hit the ground. Somebody could catch it, but the point is that a ball would fall if it wasn't interfered with. So I think this is D, and we're going to use the process of elimination to really check our work. But you have the ball being thrown and then dropping. So we really need to look at our other two graphs on the other page and see if one represents the smartphone battery and then the child taking a ride on a swing. So if you look at these two, think of the line that we drew to represent the child's swing. Up and down, up and down, up and down, forward, backwards, whichever way you want to think about it. And look at this one. You have the child kicks their legs and they go up and then they come down and they go up and then they come down and then they go up and down. You get the point. So that graph right there definitely represents the child takes a ride on a swing. So I'm going to go ahead and write B. That makes sense. Up and down, up and down. And then this one, the one we have left is a smartphone battery, which when I look at this graph, if I have the usage, right, because it says the smartphone, this shows the change in a smartphone battery charge as a person uses the phone more frequently. So using the phone, I'm going to label this usage, and then this is the battery charge. That's the two things we're talking about in that scenario. This would be like 100%, right? You charged your phone all night, you wake up, it's at 100%. As you use it throughout the day and you move this way on the graph, the battery dies down. By the time you get to the end of the school day, you have no battery because you were using it in class even though you're not supposed to. So 0% battery charge right there. It falls. So it was 100. As they used it, it fell. So that is scenario A. Okay, so that's the first problem in the problem set. Let's look at 2 as well on this problem set. Number 2. It says the graph below shows the volume of water for a given creek bed during a 24-hour period. Now, remember we talked about volume just recently in class, and volume is the amount of water that can be found in that creek bed. So the amount of water that's in that creek bed, the amount that it is full. On this particular day, there was wet weather with a period of heavy rain. So picture that. You have a riverbed, and then it's raining throughout the day, it's going to fill up. So we have our graph here. You have your volume over here, and then your time, so the number of hours. So it says here, describe how each part, A, B, C, of the graph relates to the scenario. You have part A right here, part B is this curved section, and then C. So I'm going to give you a minute to come up with your own responses to describe how A, B, and C of the graph are represented there. Keep in mind you have your time here and your volume. And we already know that on that particular day, there was wet weather with a period of heavy rain. So tell me what happens in part A, B, and C of this graph. I'll give you just a minute. keep in mind to look at how it increases. Your time goes by here, 4 hours, 8 hours, 12 hours, 16 hours, 20 hours, 24 hours, and your volume rises. And look at the rate that it rises. So I start here, and you have your creek, and then it looks like you get a little bit of rain right here through A. I would say something like, the rain begins, and the volume of water flowing in the creek begins to rise. You see it going up right here. See this part of the graph? Your y-axis goes up. And then if you look at the B portion of the graph, it increases rapidly. It looks like at about 4.5, 5 hours, they have the heavy rainstorm, about 30 minutes of a heavy rainstorm, and the volume of the creek rises a ton right there. And then for this section C, we could say it started like right here at 8 hours. The heavy rain, begins to subside or die down, and the volume of water continues to increase. So it's still, maybe sprinkling, but it's not the torrential downpour that we have right here. So your answer for this, you should have A, B, and C, and you should be describing each part of this graph just like I did. If you need to go back and re-listen to that part, then you can definitely do that.